Hello everyone, welcome back to Home Institute. This is your Sushma ma'am. We are with the chapter Electricity, Class 10, Physics. Already we discussed in a first session. Now we are moving into the next session. It is in a part 2 session. That is what we discussed in the previous video. We discussed something which is very important. How the electrons are generating electricity and all. The basic concept of electricity. And also we had generated something which is very important, that is electric current. On the examination point of view, it is very important. What is electric current? Charge, the rate of flow of charges is called as electric current. It is gonna represented by the formula I is equal to Q by T. That is I is represented as electric current, Q is represented as a charge, and T is a time. So it is gonna represented with a SI unit called as ampere. Okay, ampere. And in your 10th board exam, definitely you will get one question, that is, what is the definition of 1 ampere? Definitely you will get that in a 10th board exams. 1 ampere is nothing but the flow of 1 coulomb of charge in 1 second. That how much charge is just moving, how much charge is flowing in a 1 second. That is the flow of charge, 1 coulomb of charge in a 1 second. That is gonna measured in terms of ampere. Okay, these are all the things that we learned in the previous class. Now we'll move on to the next session, in a part 2 session, where we discussed so many things. Let me start that one. Okay, now we are with a circuit. What is the meaning of this circuit? That representation of a flow of current in a diagrammatic way. This is a circuit where the bulb is there, switch is also there, and the electrons must move on in this circuit. Then only the bulb will glow. The bulb will go with a glow, will come only with a movement of what, guys? Electrons. Again, this is negative terminal. How the electrons are moving in a circuit, guys? So that what I discussed in the previous class, there must be some energy. Am I right? What type of energy is there? It is nothing but battery. That battery should has positive and negative terminals. The battery, the source of energy should be there. The source of energy, if the source of energy is there in a circuit, then only the electrons will move. That one pressure should be there in a circuit, then only the electrons will move, then only the electricity will gonna generate it. Okay, this is a circuit. In this circuit, I'll tell you one thing, the electrons are moving in a one direction. It is from negative to positive terminal. According to actually this is correct, what I'm telling, that the symbol of electricity is in the form of like this only. But according to the old scientist, to give an honor to them, they mentioned it in the form of that electrons, that is current is flowing from positive to negative. They had discussed something which is very important. They discussed that the flow of electrons are moving actually from positive to negative. That is the way to give an honor to those scientists. We are giving a direction from positive to negative, and keep this in your mind. And very important that your circuit must contain ammeter. What is this ammeter, guys? This is a switch. This is switch, and this is ammeter. This is a device, guys. This is a device to calculate. Device calculate, used to calculate, used to write on like this, calculate electric. Something should be there, no? How much current is moving and how much the charge is flowing and everything, that should be gonna calculated with in terms of coulomb per second. But how to calculate that one? There is one device is there that is called as an ammeter. Don't forget this one. And about the switch in a battery, in a circuit, okay, in a circuit, whenever the switch is open, then there is no flow of current. Got guys? Whenever the switch is closed, there is a flow of current. So don't forget this one. Okay, this is very important. Please go through with this properly. Okay, this is about the circuit, what I discussed. The electrons are revolving in a circuit in the with the help of this battery that is called as an energy source. With the help of battery only, all the electrons are moving in a circuit, then only it generates electricity. Because whenever the switch is closed, the battery will start working, the bulb will glow, and how much the current is gonna generated is gonna calculated with the help of ammeter. Understood? So let's solve one problem which is important on examination point of view. There is one problem, guys. Calculate the number of electrons constituting 1 coulomb of charge. So it is gonna represented with a formula Q is equal to Ne. This is Q is nothing but a charge. N is number of electrons. This E is a charge of 1 electron. This E is a charge of 1 electron. Okay, guys. Now, actually, it is in the standard form. A charge of 1 electron is equal to 1.6 into 10 to the power of 19 coulomb. So, a charge of 1 electron is nothing but 1.6 into 10 to the power of 19. Please note down this one. What that asked you, that is calculate the number of electrons. The number of electron you need to calculate. So, for that, Q is equal to what, guys? Ne. Here, number of electron you need to calculate. N is equal to Q divided by E. Q is nothing but, it is a 1 coulomb of charge, guys. 1 coulomb divided by, what is the electron? 1.6 into 10 to the power of 19 coulomb. Coulomb will get cancelled. 1 divided by 1.6 into 10 to the power of 19 is there. That is equal to 0.625 into 10 to the power of 19. That I can take it as 6.25 into 10 to the power of minus 1 into 10 to the power of 19. What will come, guys? That N is equal to 6.25 into 10 to the power of 18. This is very important. Please note down this one. So how many number of atom is there in a 1 coulomb of charge, guys? 6.25 into 10 to the power of 18 electrons. How much charges electrons are there, guys? 6.25 into 10 to the power of 18. Just 1 divided by 1.6 will come as a 0.625 into 10 to the power of 19. That I converted, I shifted the point to the 6.25, so that we need to multiply with this help of 10 to the power of minus 1. So when you calculated that one, that minus 1 to the 10 to the power of 19 is there. Now you will get 6.25 into 10 to the power of 18 electron. This is very important. Please do remember this one. That how much electrons are there in a 1 coulomb of charge is 6.25 into 10 to the power of 18. Okay, understood. Please go through with this and write down properly. Okay, let's move on to the another topic which is there in your syllabus, that is electric potential and potential difference. There is slight differences there that I told you. You will come to know what is type of difference is there and all. But one thing, please note down. You are having potential difference for a class 10 physics. You are having only potential difference in a class 10. But about the electric potential and all, you will gonna learn in a higher classes. Okay, for your knowledge, just go through with the potential difference thoroughly. Okay, let me tell you what is potential difference, how the potential difference is working, what type of problems will arise in a exam and all. Let me start with a session. So potential difference is the thing that is going to learn with the help of circuit diagram. And I told you there are electrons must move. Electrons should move. Then only the bulb will glow. Am I right, guys? The electron should move whenever the switch is closed. The electron should move only with the help of the energy. So what is that energy, guys? That is nothing but battery. Battery is there. Let us take this is a positive terminal and this is a negative terminal. Yes, what is happening inside that battery, guys? That it should push an electron to move. Okay, move from here to there. Okay, just generate an electricity. It is telling something to those electrons. Am I right? Some chemical process are happening, guys. Chemical process. You will learn all those things in a higher classes. Just remember this chemical process. There is something is happening inside of this battery that is called as a chemical process. That chemical process is very much necessary for the pushing of an electron from one atom to the another atom because of the generation of electricity. It need to generate an electricity. For that, some energy should be there, and it should nothing but it is a chemical process. One thing I will wanted to discuss you. There are two terminals are there, and why we are calling it as a positive terminal and why we are calling it as a negative terminal. This is positive terminal and this is negative terminal. I can say it is a battery and all. There are some metal plates are there, guys. Okay, there are some metal plates are there. More number of electrons are there in a negative terminal. So more number of electrons are there in a negative terminal. Here the less number of electrons are there. Then we say it as a positive terminals. Whenever the battery which holds more number of electrons, that terminal is considered as positive. Where the another terminal is where it has a less number of positive less number of electron, we consider it as a positive terminal. Keep this in your mind. So something chemical process is happening inside of this battery. So it pushes the electron from here to here to here. And here just one thing, how the flow is happening inside a battery, how the flow is happening. So they're all a same kind of negative terminals, right? These are the negative terminals, am I right? Whenever the battery gives an energy, these two are negative terminal. When negative terminals are there, they'll repel each other. Because of that repulsion, guys, because of that repulsion, there is some force is gonna created here. Some force is gonna created in between these two electrons. That force pushes the electron, and next it move to the next electron. There is also repulsion is happening that pushes that electron. Like this, the pushing, the movement of electron is happening. The movement means nothing but the flow of electron. Definitely it generates electricity. Understood? This is the things that you have to remember carefully. Actually, they are both are all the electrons are having negative charged particles. How they are moving means repulsion is there. It should not get tracked. When it moves, it will go away. When it moves, it will go away. No, you are not like me. Me and you are same. We are not. We should not get attract each other. So we'll move on. So like that, the repulsion is gonna happening here. So it just pushes. It will go away and it pushes. Because of that reason, the electricity is gonna generated in this way. This very beautiful concept. I hope you all understood this one thoroughly. Okay, let's move on to the next important thing. That is potential difference. These are all the basic things you have to remember before entering into the potential difference. Okay, let's discuss with the potential difference. Before that one, I wanted to tell you something. These are the water. We'll take water in a beaker. So there is a opening, the connection between two beakers. Is there any passage is happening in this type of connection? No, because there is no pressure. Both the beakers are connected equally and both are with the same pressure. I'll take one more. See, in this diagram, there is no flow. Here, tell me, is there any flow? Definitely. There is a flow because of height. That height creates something which is very important, guys, pressure. Due to the height, the pressure is gonna created so that it passes its water to this beaker. Getting? There is a downflow of a water. This is called as a pressure. There is a pressure difference is there. What we discussed in the 9th standard, something, the movement of gas, that I had given you one example. What is that? The whatever the water or gases that should have some pressure, that should move from region of higher concentration to the region of lower concentration. You remember that one? The same thing is happening here. The much of pressure, the flow is happening due to the pressure. The same thing is happening in a battery also. The battery, whatever the pressure is going to be get builded in a battery due to the chemical process, that pressure we called it as potential difference. That pressure, whatever the pressure which is created in a battery, inside a battery some pressure is gonna created. That pressure is nothing but a potential difference. This is, keep this in your mind. The pressure is gonna created in a battery. That battery that releases some energy due to that pressure. That pressure is nothing but your potential difference. Due to this positive and negative terminal, there is some electric pressure is going to be get generated. Because of that reason, the electrons are moving from negative terminal to positive terminal. Why they are moving from negative to positive terminal? Because of the creation of electric pressure difference. That it means the movement of the electron is happening in a circuit due to the electric pressure difference that is happening inside of this battery with the help of, very important guys, the chemical process. Okay, this electric pressure difference is going to be represented, that whatever the pressure is happening inside of battery, so something is happening, right? It has to apply some energy and there are some displacements are happening. Careful, force is applying and there is some displacement is happening. Very important. Force into displacement is nothing but what, guys? Work done. Go to your kinetic energy chapter. That is, force into displacement is nothing but work done. Then now tell me, what is potential difference? The amount of work done in a work done in carrying 1 coulomb of charge. That is how much work done is happening inside this battery that generates a potential difference. Okay. That what we discussed just now. That is, potential difference is nothing but the how much work done is carried out in a given circuit. The something pressure electric potential difference, that is nothing but what is that, guys? There are some pressure is gonna build in a battery. That pressure generates that electric pressure difference between two terminals generates the potential difference. In your NCRT textbook, there is a definition is there for potential difference. This is very important. So keep this in your mind. Work done is carrying in a 1 coulomb of charge from one point to another point. So here the circuit is there, correct? This is the positive terminal. Let me introduce with the help of lines. Positive terminals is gonna represented with the bigger lines, and the negative terminal is gonna represented with the small lines. This work done, how much work is going to be happen inside of this battery in a 1 coulomb of charge, that creates a potential difference. Got it? That potential difference generates a current in a circuit. Got it? So what is the definition, guys? Work done in carrying 1 coulomb of charge from one point to another point. How much work is going to be done in a 1 coulomb of charge from one point to another point movement in a given circuit is called as a potential difference. Please note down this one. This is your NCRT textbook definition, and definitely you will get such a kind of question in your 10th board exam. Okay. Now tell me how to represent this potential difference with a capital V. So why V and all, I'll tell you later. V is equal to work done divided by what, guys? Charge. Work done divided by charge. Now tell me, work done is represented in terms of joules and charge is represented in terms of coulomb. So now tell me, what is SI unit of potential difference is joule per coulomb. Joule per coulomb. That is, SI unit for a potential difference is given by joule per coulomb. The work done is going to represented in the terms of SI unit called joules, where charge, that I already teached you in a previous video, that is, charge is represented with the help of coulomb. So what is the SI unit of this potential difference? Is nothing but joule per coulomb. Okay. I told you SI unit of potential difference is joule per coulomb. On the honor of one of the scientists, Alessandro Volta. He made a lot of contribution to the electricity and all, and he explained something which is very important on potential difference. On honor of this scientist, the SI unit for potential difference is nothing but volts. They are represented in terms of volts. Please remember this. This is very important. This is the SI unit for potential difference. What is the SI unit of potential difference? Joule per coulomb is also correct. But on honor of Alessandro Volta, we represented it as a volts. Okay. This is very important. Keep this in your mind. See, let me write on very important term, that is 1 volt. That is 1 volt is going to represented with help of work done divided by what, guys? Charge is there, right? That 1 volt is going to represented as 1 joule divided by 1 coulomb of charge. The definition is very important. Take down. The potential difference potential difference where 1 joule of work done carrying 1 coulomb of charge is called volt. 1 volt. The definition of 1 volt is nothing but the 1 joule of work done is how much it is created, the potential difference. In that potential difference where 1 joule of work done is carrying in a 1 coulomb of charge. This is the very important definition in a 1 volt, which is a SI unit of what, guys? SI unit of potential difference. You may get a question like what is 1 volt, or they may ask what is the definition for SI unit of potential difference. This is very important. Go through. Okay, this is about potential difference and the SI unit of potential difference, what we discussed just now. Let me end this session. If you have any query, please comment those queries in our comment box. And in our upcoming sessions, in the next session, I'll discuss some numericals on these topics, whatever the thing we discussed today. Some numericals are there. And the next law, one law is there, that is Ohm's law. We'll discuss in a upcoming videos. And do not forget to share my videos, and please do subscribe the video and support me. Just now we discussed something which is very important for a 10th standard board examination point of view about volt and all. The potential, this is the SI unit of potential difference. What is the meaning of potential difference? What the pressure which is going to build on a battery, how much the work is going to done with a 1 coulomb of charge, that is called as a potential difference. And the SI unit of potential difference is work done divided by charge, that is nothing but joule per coulomb. That is due to give an honor of one of the scientists, Alessandro. We had given on honor of him, we had mentioned SI unit of potential difference as volt. Okay. Now we'll discuss something which is very important about the potential difference and all. So look at this, guys. What is this? A battery. Correct? Battery which we are using for TV remotes and small instruments and all. They're working on the kind of these things. Am I right? The battery has, that is actually this battery has 1.5 volt. What is the meaning of this 1.5 volt? That much potential difference is there. That much pressure can be built under this battery and all. Okay. This 1.5 volt means 1.5 joule of work done to carry what, guys? To carry 1 coulomb of charge. Okay, to carry 1 coulomb of charge. 1.5 joule of, what is this? 1.5 joule of work is gonna done to carry a 1 coulomb of charge. So similarly, 9 volt means that is 9 joule of work done to carry the same 1 coulomb of charge. The how much work is gonna done, that is how much pressure is building in the battery itself, called as a potential difference. That all you know. And in our homes, this is not the examination point of view and all, just for your knowledge. In our mains, in our power supply, we use about, in our home and all, it is about 220 volt, guys. Whatever the home, every home has some potential difference, that is 220 volt. It is government got restricted, only this much of voltage should be there in every house. This is your extra knowledge. So just keep this in your mind. This is in a house, in a home. Every home we are using 220 voltage. That is 220 volts of potential difference is there in every home and all. This is about the potential difference and about the battery and everything. Now we'll move on to our next topic, that is which device is gonna used for the measurement of this potential difference. Okay, this is one circuit that what I mentioned just in the previous classes and all. That is circuit diagram that I mentioned in the first class, that how we have to represent the circuit diagram and everything. Ammeter is there. It is a device used to measure what, guys? Current. Correct? Electric current is gonna measured with the help of a device called ammeter. And which instrument is used to measure our potential difference? This is very important. That is voltmeter. Voltmeter is used to measure. Voltmeter is an instrument used to measure what, guys? Potential difference. This is very important. Note down this one. One point. Potential difference. Take down. Potential difference is measured with the help of an instrument called what, guys? Voltmeter. Now just observe. The path is same here. The path is similar. I mean, same path is there for a ammeter. Am I right? That ammeter got connected in a same path. This type of path is called as series connection, guys. This is series connection. Ammeter got connected in a same path. That's why this type of connection is called as series connection. But look at here. The voltmeter got connected with another wire, and this type of connection is called as parallel connection. You will come to know about the parallel connection and series connection in upcoming sessions. But please note down this point. Voltmeter should be connected in what, guys? Parallel. This is very important. Okay, please keep this in your mind. Ammeter, it is passing in a same path, that's why it is connected in a series, where voltmeter connected in another path, that's why it is connected as a parallel. Please note down these points carefully. Whatever I am writing on a board, please do write down carefully, and please do watch my video till end. Okay, this is very important. Okay, let's go with the numericals. These are all the numericals are there in your NCERT textbook. Okay, let's solve. This is the first problem which is there for your potential difference and all. Just look at the problem. How much work is done in moving a charge of 2 coulomb across 2 points having potential difference 12 volts? From one point to another point, it has to get moved by using 2 coulomb of charge. How much potential difference required? It means how much work is done. Okay. Before moving into anything, what I told you in the previous class, please mention the given things. This is very important. If you know whatever they had given, it is very easy for you to solve the problem. Okay. This is the main thing that you have to learn in a physics. Okay. Let me write what they had given. That 2 coulomb of charge means what, guys? Q. Q is equal to how much? 2 coulomb. And 2 points having potential difference. What is potential difference? That is V is equal to what, guys? That is 12 volt. Okay, what we need to calculate? Work done. That is W is equal to, we need to calculate. This is very important. Work done, we don't know what is work done, that we need to calculate work done. And we know one formula regarding potential difference. What is that? V is equal to what, guys? W divided by Q. Correct. What is V? that is potential difference, W is work done, and Q is a charge. This is the relationship between potential difference, work done, and a charge. What they had given, V and Q they had given, we need to find W. So V into Q is equal to W. It implies W is equal to, what is V guys? 12. And what is Q guys? 2. That is equal to 24. Work done is always measured in terms of joules. What guys? Joules. So what is your answers? 24 joules. Please note down this. This is very important. This is your second problem in a NCERT textbook. What is meant by saying that the potential difference between 2 points is 1 volt? Just now I had discussed something with you by showing a battery, correct? What I discussed there, that is that battery has 1.5 volt. What does it mean? That battery having that pressure between 2 points, that is 1.5 volt. According to the definition, what we have to mention here, 1.5 volt of work is done. There I mentioned, correct? Here, how much they had given? 1 volt. So what you have to write down here? The 1 joule of work is done to carry 1 coulomb of charge from one point to another point. Just write down that one. That is your answer. What do you have to write down? 1 joule of work is done to carry 1 coulomb of charge travel from one point to another. This is very important. This kind of questions we're going to ask in a multiple choice questions. Okay, so careful while answering such a kind of questions. Okay, write down. And this is your third problem. Just read the problem properly. How much energy is given to each of charge passing through a 6 volt of battery? Each charge means what guys? Single, correct? It means Q is how much? What they had just mentioned given. This is very important. Okay, Q is equal to what? 1 coulomb, and passing through a 6 volt of battery, V is equal to 6 volt. Energy, nothing but work done. So just take down V is equal to W by Q. W is equal to V into Q. What is V guys? 1 into 6. That is equal to 6 joules. So your answer. 6 joules of energy is given to each for a 1 coulomb of charge passing from one point to another point of a battery by using 6 volt of potential difference. This is about the problems, whatever which is there in your NCERT textbook. This finishes your some problems regarding potential difference and all. In my next video, we'll move on to a very important concept, that is Ohm's law. This is very, very, very important concept. That Ohm's law, the problems related to the Ohm's law, everything we're gonna solve in my next video. Please do watch and share and subscribe. Okay, thank you.